All right, so we're going into our fourth one where we're going to move away from those remainders a little bit, and we're going to start our plugging things in, our compositions or multiplications, but now we're going to start integrating and differentiating power series. Right, we're in calculus, that's what we do. Lots of words. Lots of words. Yep, skipping past it. You saw it? I want to try a problem. There we go. So f of x is equal to 1 over 1 minus x that we can represent as the sum from k equals 0 up to infinity of x sub k, which would be equal to 1 plus x squared plus x cubed plus dot 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 continues on forever. So we want to differentiate the series and find f prime of x. Now this is kind of similar to the rules we learned with derivatives and integrals, that we can go what's called term by term. If you have some pluses, and that's what it's equal to, then, well, gosh darn it, let's go. But the only thing we need to make certain of is, oh, I lied. It's true. It's only going to work for x values, or the absolute values of x values. They're less than 1. So anything in between -1 and +1, this wouldn't work. It tells you at the beginning. So let's start off with differentiating the series, and, well, shoot, let's find f prime first. F prime of x is equal to, and I'm going to jump past this, this is -1 over 1 minus x all squared. Neat. Okay, cool. 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 We did it. We found f prime of x. We're like, woo, I can take a derivative. If you're still not able to take derivatives on things like that, how's your score in this class? That stuff from before really matters, doesn't it? Oh man, it just keeps building and building and building. And then you get to Calc 3, and then you got to know everything Calc 1 and Calc 2. But it's not so bad. I think you're in the toughest of all of the calculus right now. So now we want to find out what's the derivative. Now, I don't want to mess around with that nonsense. I just want to look and go like, well, wait. This could be represented as this being equal to, what's the derivative of 1? Nothing. What's the derivative of x? 1. What's the derivative of x squared? 2x. What's the derivative of x cubed? 3x squared plus, oh, that'd be 4x cubed plus dot dot dot. It would continue on forever and ever and ever. But let's set this thing up as a sum. Now, we'll lose that first term. We're like, I don't want that thing. We're like, well, let's write this as a sum. So let's start at 0 up to infinity. Now, it looks like our first term is 1. So when we plug in k equals 0, so let's look at our coefficients. 0th term, we get 1. First term, we get 2. Second term, we get 3. So the coefficient needs to be 1 more than the index. And then it's just x to the k. Right? We see it. 0th power, 1st power, 2nd power, 3rd power, 4th power, 5th power, 6th power. And we have our sum. And we have just taken a derivative on a series. K plus 1 times x to the k. So that's why I didn't take a derivative on the actual interior piece. It doesn't quite turn out to be the way you think. It doesn't turn out the way you think. It actually totally does. You just have to change terms. It totally does. Moving on. So we found f prime of x. Now let's integrate the series, huh? Let's integrate the series. So for number 2, what are we integrating? 1 over 1 minus x. So clearly the integral of f of x dx is just going to be the negative natural log of 1 minus x. Absolute value, of course. And then there's a plus c. Yes? There's some sort of plus c. Cool. C doesn't really matter. It really doesn't matter. But, shoot, you plug in x equals 0, and that thing still, c is equal to 0. But I'm just going to jump past that. All right. Now, we can say that this is going to be equal to the integral of all of our terms. Huh? So we're going to take an antiderivative on 1. That's x. We're going to take an antiderivative on x. That's x squared over 2. Take an antiderivative on x squared. That's x cubed over 3 plus x to the 4th over 4 plus dot, dot, dot. It's going to go on forever. And there's actually a plus c in here as well. We're going to ignore that plus c. We're just going to kind of ignore it. But we now have a new power series, which tells us the negative natural log of 1 minus x is actually equal to x plus x squared over 2 plus x cubed over 3 plus x to the 4th over 4 plus dot, dot, dot. It's going to go on forever. We're ignoring those constants anyway. Just look, they go away. But it actually, that's not technically why they go away. We're going to ignore that for now. It's not going to actually work out too horribly. And if you don't mind, I'm going to multiply by -1 here because, well, we have it. We have our antiderivative, but I'm trying to make a point, right? I probably fall short, and I want to multiply them by -1. I say -1, and I write a positive. Of course I do. Come on, dum-dum. So all of these are negatives now. We're just looking, and we're like, oh, I wonder what the negative natural log of 1 minus x might be. And let's write it out as a sum. Or actually the positive. So we could take that negative out. I'm sorry for being a dick. Plus, 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 plus. So it's negative the sum of k equals 0 up to infinity. But how do we write this? Do we want to put it in? Like, I'd almost rather re-index this. Like, wouldn't it be nice if we started at 1? Think about if we started at 1. First term, second term, third term, fourth term. They match up. All the numbers work out beautifully. Because if we don't do this, I'm just going to jump to it and I'm going to change it right back. This will end up being, down at the bottom is a k plus 1. Up top is going to be an x and k plus 1. And that's correct. That's 100% correct. There's nothing wrong with what is just written. There's nothing wrong with it. It is 100% correct. But I want you to be able to know why this stupid book just changes up the index and goes, whoop, now it's just x to the k over k. Those are the same things. And our interval of convergence will still be the same thing, just like it was for the derivative. We're going to keep those same pieces. There we be. There it is. There's differentiating and integrating. It's not so bad. You just go term by term. I think a lot of the struggles would be actually just solving for this at the end. Solving for this at the end. I think you all have the capabilities. You have this. Dude, you can find antiderivatives. You can find derivatives. It's not that bad. But. Yeah, dude. All right. I'll see you in the next video. Later.